because Leo had asked us to do that. Okay, it just shows how easily it is to forget. So let's share now Desmos so that we can all have a look what it would look like. So if I go to, I'm going to start sharing Desmos, guys, so you can have a look how it functions. So you should be able to see this, right? So if I click on Desmos, you get www.desmos.com. You just click on Graphing Calculator. We're going to start plugging some of these functions that we just mentioned. So the first one we had was f of x equal minus 7x plus 31. So as you can see, it is a straight line. So we've got an equation of a straight line because it's in the format mx plus c. The second one was f of x. So I can call it y as well. It's the same thing, 2x plus 4. So either f of x or 2x plus 4. So can you notice something that the two straight line intersect at one point? So I'm going to try another one, 5x minus 5. So y equal 5x minus 5. So if we do this properly, they should all intersect at the same point. And what do you think that point is going to be? What is the point that we were looking for? Can you see it? 310. Is that visible on your screen?
Yeah.
So basically they all intersect there. So let's put one of the fancy ones and see what they would look like. So the square root, so we got y equal, so to get the square root, you click on the keyboard there, square root of 5x plus 85. Okay, so again, you can see that it's not a straight line this time. And I might put one of the ones like we got. So let's try the cube root one. Y equal, so cube root. So to do cube root, I think it's a bit more complicated. I would need to, I'm going to use to the power a third because cube root is the same as raising it to the power third. So minus x squared. So this is what cube root is, to the power of a third. And then we need to add 8. As you can see as well, that this function here that was given to us go through the point 310 as well. Okay. So it's good to use Desmos because it would help you to see exactly what we've done. Okay. So let me share back today's lesson. I know I've got a memory of a Sev. So I did say you were given some homework today, and one of them was to look at factorization. Okay. So you should say here factorization. Factorization exercise was what you were looking at. So I did get some answer from you guys. I think that's good. At least I'm seeing people giving it a try. Most of you are getting it okay. There's some still that are a bit more complicated. But what we were told is when you try to factorize, you use 3 methods. Okay, so you need to go through three steps basically. The first one is because we've got a quadratic here, they're in trinomials. We call them trinomials because you've got three set of data. One has got x square, another one with x to the power 1, and it's trinomial because the next one is, believe it or not, x to the power 0, because x to the power 0 is the same as 1. Okay. So, do you see here a common factor between the invisible one, the 10 and the 16? No. So that means to factorize this, you can use different approach. So what you'll hear people telling you most of the time is they would go, because I've got the factor of x squared as being 1, the answer should be x something times x another factor. I need to find those two numbers here, a and b. So how do we find those two numbers? If you think about it, when you start expanding this, you do x times x, which is x squared, and you finish by the number next to the x times the number next to this x here to give you 16.
Adrian, sorry to interrupt. I'm not too sure if we are meant to see a screen here. I can just see you.
Ah, okay, sorry. Let me put that back into sharing. So I thought I was sharing there. Share screen. Okay, so can you see it now?
Yeah, that's it.
Okay, so factorization exercise. What I meant was here we've got an invisible 1 in front of x squared, a 10, and a 16. So if I was writing this ax squared plus bx plus c, you could see because I've got a 1, the easiest way to factorize this is to find the two numbers that when you time them together, you get 16. Okay, and when you add them together, you get 10. So that's the method that I usually use all the time, and it works. I call it my foolproof method because I call it MAM, M-A-M, where I'm looking for two numbers. So remember here we've got an invisible 1, such that m times m, which is 1 times 16, makes 16. So when you time the two numbers, you get 16. And when you add the two numbers, I get 10, positive 10. What are those two numbers? So those two numbers, you can try it by error. So you can do 1 and 16, but that doesn't add up to 10. The next one is half this because it's an even number, 8 and 2. So if I try 8 and 2, you can see that 8 times 2 equals 16 and 8 plus 2 equal 10. So I've got my two numbers. Then it's just a matter of plugging those two numbers here, positive 8, positive 2. And that's how you would factorize this trinomial, okay, which is a quadratic. So any question with that? So at this stage, now that we're going into quadratic, everyone should be able to do this. Okay, so these are the simple factorization. If you still think I'm struggling, I don't understand what to do here, you need to contact me, guys. So that's the first one. The second one is exactly the same because I've got an invisible 1 here. That means I can just put x and x, but I need to time the two numbers to give me 16, and when I add them, I get negative 10. So this time, because I need negative 10, I can use again 8 and 2, but I need to do negative 8 plus negative 2, which give me negative 10. So my two numbers are going to be negatives. And you can just say x minus 8 times x minus 2. I've seen some going into even the trouble of checking. So you're allowed to check your work. So you would do x times x, which is x squared, minus 8x, then minus 2x, negative 8 times negative 2 plus 16. So I've seen folks even trying that when they're finished, which is excellent because that means you are checking that what you gave does work. And that gives you the sense of, at least I know that I got this right because I've checked my work. Okay, so nothing stopped you from checking your work. So I've got another 2 here, 3 and 4. So this time I've got 16 again. So I would put x. So 2 numbers. This time is going to be again 8 and 2. But one number has got to be negative and one number has got to be positive because I've got a negative 16. And the bigger of the two, because I've got positive 6 here, has got to be the positive one because positive 8 minus 2 will give me positive 6. So Nasus, we've got this answer. For the next one, the bigger of the two this time has got to be the negative one because I've got negative 6. So that's going to be x minus 8. And to get a negative here, I need to time it by a positive. And that's your x plus 2. So anyone found any difficulties with going through these so far? Should be pretty straightforward, yeah?
Yeah.
Yeah. So on the next one, we've been asked to factorize. I can see a common factor. The common factor between x squared and 6x, remember x squared just means x times x plus x times x. That's what 6x means. So I can get x out from my bracket and just put x plus 6. So if I'm asked to factorize this, I found a common factor between the two here, and I've just factorized it. Okay, same here, but it's minus 6. So x times x minus 6. Common factor. Now, when you get to this here, x squared minus 16, we've got what we call a difference of two squares, guys. Yeah, so difference of two squares. And if you remember well, we can see the two squares. The first one is x squared and the second one is 4 squared. So that's one thing you need to learn by heart is the square numbers. 9, 16, 25, 36, 49, 64, 81. These needs to be in your head whenever you're going to be asked to factorize, because if they appear on their own, think they are square numbers. And that we've all seen that it's x plus 4 times x minus 4. Or x minus 4 times x plus 4, same thing. Okay, so I've seen a few that didn't spot this. So they need to probably revisit some of the lesson that we've had in the past. The next one, 2 is even, 18 is even, 16 is even. First thing that should come into your head is they're all multiple of 2's. The first one is 2 times 1 give you x, 2 times 1 give you 2, minus 9x plus 8. And again, you use the MAM method. I'm looking for two numbers such that if I time them, I get positive 8. And if I add them, I get negative 9. Guess what? 8 and 1 would bring me to a 9, but I need to have them both negative. So -8 and -1. So you just replace all this with 2 times x minus 8 times x minus 1. And this, guys, was 3 marks. 1 to spot that you've got even numbers, 1 to spot that you found the 8, and another one, the 1. Same for the next one, but this time they are going to be all positive. X squared plus 9x plus 8, which give us x plus 8 times x plus 1. Again, 3 marks. Okay. So who struggled with that? Because this is where the struggle will start to come now. When I get something like this where I can't have 2 as a factor. So now I've got here 2 as a factor of x squared. Okay, so 2 school of thought here. Some people would say, I can try what we call trial and error. So I can put here 2x something, x something. That's not my favorite method, but some people use it. But remember, 2x squared will come up, but I need 16. To get 16, I can try 8 times 2. So if I put an 8 and I put a 2, would that work? This way, it might not work because I'm going to get 8x plus 2x. So 8x plus 2x plus 4x, that's 12x. So that doesn't work. Yeah. Which is why I'm not too fancy. I don't fancy too much the trial and error. The other one, we could try 16 and 1. But where do you put the 16? That's the question that comes up to me. People would tell me, why do you put the 16 on the right? Because I'm just trying something and see if it works. Do we like math to be trial and error? You will get the answer, but to me, that's not the best way to do it. So to get -33, if I put -16 here, -1, and I try this, I get 2 times 16, that's -32x, and then -1x, -33x. You did get your answer, but it took us a bit of pain to go through it. And this is where I use something else called MAM, which work all the time and doesn't give me into the bother of trying and error. So I'll show you on the next one what I mean by that. MAM, if you remember, would have I'm looking for 2 numbers such that if I time them, I get 2 times 16, which is 32. And if I add them, I get 33. What are those 2 numbers? If I time the 2 numbers, I get 32. And if I add them, I get 33. Can someone think about that? No? Any ideas? $32 and 1? Yeah. That's a very good idea. Because if you put 32 times 1, it gives you 32. And if you do 32 plus 1, it gives you 33. Those are my two numbers. So now, what am I going to do with those two numbers? I'm going to replace that 33x with 32x plus 1x plus x. And this is where mum comes to play, because 2x squared plus 32x plus x plus 16 give me the chance now to factorize this section and see with this section. And that is 2x times x plus 16 plus on its own x plus 16. Technically, that is plus 1. There's an invisible 1 here, x plus 16. And now I can put x plus 16 as my factor, because it's x plus 16 times 2x for this part, times 1 for this part, plus 1. And without doing trial and error, I've managed to get my answer. Yeah. And you could do the same for this one. This one you would get 2x minus 1 this time, times x minus 16. No. So x minus 16, 2x plus 1, because we need to have a negative. Negative 16, negative 32 plus 1, which is negative 31. Okay. So if I had used mum, I would have done it properly without thinking this one and this one. Next one here, I've got 4x squared minus 16. So some people went and say, oh, what is the first thing we need to see? I've got a 4 and I've got a 16. They're both even, but if I halve them, I get still both even numbers, 2 and 8. So that means I can halve them again. So if you halve twice, that means you divide by 4. That means 4 is your common factor. So you can change that as a 4 times x squared minus 4. And this time you've got a difference of 2 squared, which gives you 4 times x plus 2 times x minus 2. Now, if you had said, oh, I can see difference of 2 squares because I've got a 2x squared minus 4 squared, it's okay to write 2x plus 4 times 2x minus 4. But remember, the question is you need to factorize and give your answer in its simplest form. So you can extract 2 here and you can extract 2 again. So 2 times 2 would give you 4. And then you get your x plus 2 times x minus 2. So you would get the full marks by making 4 as, yeah? So 2 times 2 basically. Any questions? On the last one, actually the last one is probably easier than the ones before that, because what you could see from the last one, you can just rewrite that as 4 times x squared plus 3x minus 4. Yeah? Two numbers, 4 and 1 would work. So you would say x 4, x 1. The positive one has got to be the bigger of the two. because I've got positive 3 here. So then that's plus 4 minus 1. And that's how you would get your 3 mark for this one. So we need to be able to do these guys. And remember when I said to you, a foolproof method? This is why the foolproof method works. I'm going to do this again this time, not all of them, but the ones that people found a bit harder or didn't spot it. If I use MAM and I try to factorize x squared plus 6x, let's say you can't see that x is a factor. This is the same as adding 0. So if I'm asked to factorize this, can I use MAM? Of course we can, because we've got M, A, M. I'm looking for two numbers. If I time them, I get 1 times 0. What's 1 times 0? 0. And if I add them, I get 6. You can only get two numbers timing each other to give you 0 if one of them is 0. So one of them will be 0. To add, the other one would be 6. 0 plus 6 will give you 6. My two numbers are 0 and 6. Guess what? X plus 0 times x plus 6. And hopefully you will be able to spot that adding 0 to a number is the same as if nothing was here. Oh, that is x times x plus 6. MAM worked on something that you didn't spot to start with. Now, let's use MAM on a difference of 2 squares. Yeah? This is the same as x squared plus 0x minus 16. Let me try MAM again. M, A, M. Two numbers, when I time them, I get negative 16. And when I add them, guess what? I get 0. If you add two opposite numbers, you will get 0. So my two numbers got to be opposite in sign. What are the two numbers that are exactly the same, which give me 16? But one is positive, one is negative. Guess what? It is negative 4 times positive 4. Do I have to remember the difference of two squares? Not really, because I know that if I add negative 4 and plus 4, I get 0. You could just come here and say this is x plus 4 times x minus 4. Your two numbers, that one and that one. So without remembering a difference of two squares, without remembering that I need to extract a factor, I showed you how to use MAM above when you've got here a number bigger than 1. That's why I keep saying to people, if there is one thing that you should learn and should use to make sure that you always get these right, is a method that always works, guys. A method that you don't need to think about, I'm going to try this or try that, see if it works, see if it doesn't work. I don't need to remember a difference of two squares. I don't need to remember. I need to find a common factor. So what more would I need if I can just master this method? So I don't know how I can say to folks, to you guys, the guys, especially the ones that are still struggling. But if you want to learn what we call a foolproof method, this is the proof. Okay. So any questions? And like I said, there is a video on Canvas showing you step by step how to use MAM. And I can tell you, a few years before, when I was sitting in these rooms watching people doing nat5, didn't have Canvas, didn't have lesson that were recorded. You don't turn up, you don't learn. So you've been put everything to make it as easy as possible. The only thing asked from you is to spend the time to do it. So that bit I can't do for you. Okay. So I hope you don't think I'm ranting about, but this is the bit that I wanted you to see, guys. What does it say? The nat5 course is a big course. You will be doing the same exam as some children that have been there for 2 years. For 2 years, they get 4 at sometimes 5 periods of math every week. So those are the ones that you're going to be competing against. You've only got 8 months to do it with 3 hours per week. And like adults that we are, we work, we do other things. So if we don't put the work behind, so it's essential that you get through the stuff that has been said for you every week. And the best way to remember all that work is, what is PPP stands for? If you want to be good in golf, what do you need to do? Practice, practice, and practice. Yeah. And if someone asks me, what do you advise me to do? I would say that. And I can put my hand up to say that if you do that and you go through it, you will pass. Now you might think, oh, this is halfway through the year, a bit more. We're 2/3 in now. Is that too late? It just depends how much time you want to put in. Okay. So any questions? So now I'm going to show you a problem, a past paper problem. Which year was that? 2019. It was paper 1. This is where it comes to play, factorization. I've got a bowl. Can you see it okay? Yeah, it seems to be quite small, but I've got a bowl that is kicked from a cliff top in 2019. That's the question they had. The height in meter is represented by here, h. This is y of f of x. This time, instead of x, they've used t, so it's f of t. Calculate the height of the bowl above the cliff after 2 seconds. So remember what we looked at with function? F of t here equal 12t minus 5t squared, right? Now they've said t equal to, what is f of t, or what is the height? So height, when t equal to, is 12 times 2 minus 5 times 2 squared. So now I could say to you guys, you could use a calculator. Unfortunately, paper 1, no calculator. 12 times 2, hopefully you'll be able to see that's 24. 2 squared. 2 squared. In order, we do bracket order. So, and this is 4. 4 times 5, 20. 24 minus 20 is 4. So calculate the height above the cliff top. So the height above the cliff top, because they've said here the height is in meters, we just write 4 meters. So when this rugby player or football player, whatever you call it, kick the ball at time 0, after 2 seconds, the ball will reach 4 meters. Okay, so that's what it means. And that's your first mark. 1 mark for this. And that's why we ask you try this function f of 3 equal 10, because if you had tried it and you had found a function in this format, 12x minus 5x squared, then you would know that whenever you're going to get a value for t, you need to replace the t with the value. And hopefully, visually, by having tried it, you would remember the day of an exam comes. Okay, so we're not asking you guys to do things just to waste your time. It's more for you to start having some triggers that would help you when you're going to get a question like this. Okay, so that was the first question. And I would say it's a problem-solving type question, but it's only worth 1 mark. But here you just replace t with 2. 12 times 2 is not big math. 5 times 2 squared is not big math either. And that's why they don't give many marks for these. Now, the second question is a bit more complicated because as you can see straight away, you could get 4 marks out of that second question. So let's read the question. After how many seconds will the ball hit the sea? Remember the sea is at this level. H equal -17 when the ball hit the sea. So maybe some of you might say, but that's not. Yeah, there you go. The sea is 17 meters below the cliff top. They even told you that is -17. So I can see that maybe you might have written 17 instead of -17, but never mind. If you had written 17, you would have lost 1 mark. So you could still get 3 marks. But because it's below the 0 line, it's -17. So what is t? What is t when h equal -17? That's what we need to answer. H equal -17, 12t minus 5t squared. I like my number when there are net positives. Oh, 12t minus 5t squared. So I'm going to move the -5t on this side. That becomes 5t squared minus 12t minus 17 equals 0. So that's what we've been asked to solve. And why do you think we've got a quadratic? Because if I was to finish this looking like function, you can see that you've got a quadratic and you do have what we call a turning point there, if you've done some of the work that you've done so far. But that's not the question they've asked us. They've asked us after how many seconds, which is find that t here, which is a positive time. So I've got 0 seconds. We notice that after 2 seconds, we're at 4 meters. After how many seconds we will be at -17? That is the question. So you need to factorize this, I would call beast, because when you have a big number here, things becomes a bit harder. This is where you need to use MAM. So guys, these are the type of questions that are asked during an exam. Some of you are probably looking at this thinking, there is no way I can go through this and factorize this. But look, we're going to use MAM. Once again, hopefully that will come to our rescue. MAM tells me that the first factor is 5. If I add the 2 numbers, I get -12. And if I get the other m, it's -17. So m times m, 5 times 17 is a big number. Just write 5 times -17. I've got 2 numbers here. If I add them, I get negative 12. Guess what? If you add these two, do you get negative 12? Yes. So I've got my two numbers, 5 and negative 17. Did you see the trick that I've used this time? I didn't go and started multiplying these because that's not what I need. I'm looking for two numbers. I can try 5, I can try negative 17, and it works. So I'm going to replace now my negative 12t with 5t minus 17t. So let's write that down. Very good. So 5t squared, I said plus 5t minus 17t minus 17 equals 0. So those two numbers, 5 and negative 17, I'm using them and I've just replaced that negative 12t because now I've got what we call common factor that will help me to factorize that first part and that second part. And those common factors are 5t for this one, times t plus 1. And the second one, minus 17 times t plus 1. If you've done your work correctly, you always see that those two will come back up again. And now I can factorize using t plus 1 times 5t minus 17. So something that looks unwelcoming at all from the first word go, I've used MAM and MAM got me out of jail, factorize it for me without having to think twice, apart from the fact that I didn't multiply 5 and 17 because I'm looking for two numbers. Okay, so maybe if we've learned one thing today, guys, is to try and do it that way. So now I've got two factors. When would they be equal to 0? These are what we call roots. When t equal negative 1, or 5t minus 17 equals 0, 5t equals 17, or t equals 17 over 5. And you can leave it like that. If you want to know roughly what it is, you can rewrite it as a mixed fraction. 3 times 5, 15, 2/5. So 3 second 2/5. So either negative 1 second, we will be at that negative 17 line, or 17 over 5 second, we will reach this negative 17 level. Which one do you think we should pick? The negative one or the positive 17 over 5? So to get the mark, since t is positive, the only possible answer is the positive one. Solution is t equals 17 over 5 second. You write this, you get your final mark. If you want to write it as 3.4 second, you can do that as well, but you don't have to. So this one is not a correct scenario. So any question on this, guys? What was the difficult part? Is I would say probably to understand what you've been asked to do, yeah? So to be fair, what is t when h equal negative 17? So I've seen people putting positive, but that's what they ask you. So 5 marks. And back in 2019, I think there was no COVID at the time, so people would have gone through a full school year without interruptions. Okay. So these are the type of question you might get. All right. What other type of question you guys might be asked to do? You might be asked to find point of intersection between a curve. Remember, we said these were a curve and the line. So if I give you this as an exercise to do, first thing I would expect you guys to do is this. What is this? I'm looking for intersection of x squared plus x plus 1 with a straight line 2x plus 1. Desmos is giving you already the answer that you're looking for. So now, what do we need to do to find the answer? As you can see, at the point of intersection, y for this line is equal to y for this other parabola. So that's why the first thing you need to do is, if y is this and y is this, then x squared plus x plus 1 must be equal to 2x plus 1. So now we're going to group everything on one side and try to do some factorization work again. So if I move 2x on that side, I get x squared minus 2x plus x. Then if I move positive 1 on that side, I get positive 1 minus 1. And all that will be equal to 0 because those two have moved. The good news is those two cancel each other and I end up with x squared minus x equals 0. And hopefully you would have seen that you've got to factorize that with x minus 1 equals 0. And because we've got a quadratic with the number 2, I need to give two answers. First answer, x equals 0. The other answer, x minus 1 equals 0. Add 1 both sides, x equals 1. So when x equals 0 or x equals 1, we will share the same y. So what are those points of intersection? So what is y when x equals 0? Y equals 1. The good thing is for both. So when x equals 0, y equals 1 when you substitute it to either or. So point of intersection 0, 1. And when x equals 1, so you could use the second one, 2 times 1 plus 1, y equals 3. Second point of intersection, 1 and 3. Let's quickly check that that's what we got on Desmos. Guess what? It is. So you could have gone through this and quickly plug these two functions on Desmos. 1, 3, 0, 1 are your points of intersection. Okay. And this is how you would solve this problem using factorization again. So far, we've just been using factorization. And that's why we keep telling you that factorization is a very important topic, because a lot of marks during that exam that you will sit are going to call these skills back from you. And the more you're going to practice them, the better you're going to be at them. And then you start practicing some of these questions that you can find on the National 5 Math website, where they've got hundreds of different questions to try. Or if you don't want to go there, Canvas, you've got plenty Pegasus work there. Okay. And we're not fully ready to go through the full past papers, but there are websites that give you some past paper question based on a topic. All right. So we've seen a curve meeting a line at 2 points, yeah? If you've done the lesson this week, you've been taught that b squared minus 4ac is what we call a discriminant. So in this example here, you get 2 roots because b squared minus 4ac discriminant is positive. That's why you get 2 roots. Yeah, 2 real roots. If you've got what we call just one point of intersection, then it's what we call a repeated root. And that happens when b squared minus 4ac is equal to 0. One repeated root, we call it. A real double root, even if there's only one connection. And sometimes you will get a solution where you won't find a solution. And if that happens, you just write no real roots. As your discriminant in this case would be negative. And why do we not get a real roots? Because the quadratic formula is given to you right at the start of the formula sheet as x is minus b plus n minus the square root of your discriminant over 2a. So you don't need to remember this by heart. So if you've got b squared minus 4ac negative, we can't take the square root of a negative number, then you just write, I've got no real roots. If it's 0, you've got a repeated root. And if it's positive, you got 2 real roots. So if you've done that lesson on discriminant, you would have seen these. But once again, me just mentioning you that, it will go in, depending what you're going to do with it. A lot of it will come out. And it's only when you're going to start doing these exercises where they ask you these specific questions that it will stay in. Because at the end of the day, that's what you want. You want it to stay for the big day. Okay? Any questions? Any question with discriminants? Because from tomorrow, you should be now starting on the trig. Okay, so if you are catching up, then you need to be catching up fast. Yeah? No, no questions? Quite happy? To be honest, we're nearly done. So I probably rattled through quite a few things, but I'm trying to give you some foolproof method that I hope some of you will probably use if you are still struggling. Okay? Because at the end of the day, that's what you should be looking for. Something that is worth learning because you know it's always going to work. I didn't know MAM before, so I used to do a lot of trial and error. The teacher I had taught me with trial and error. But I went and showed that teacher me going through looking at different things. Oh, there's a method here. And the teacher that taught me is happy for me to give those hints. Okay? And that's how it should work. I learn a lot from my teacher, but today my teacher is happy to learn from me. Okay, so quadratics, we've done quite a lot on quadratic. There are some revision. Yeah, so when we're going to be doing revision for the exam, you're probably going to touch on these. Exercise 19E, 19F, 90G. So they are the trickier problem solving one. Okay, so if you are trying to get through them and you're struggling, let me know. I've been through them, so I can give you the solutions or I can walk you through them, but you can keep them for the revision before the exam, okay? And remember what we said on Leki. If you are quite comfortable with going through the star exercises, those are the minimum that are required, okay, to get you through at least a C. Next topic, trigonometry. Trigonometry would stand for 3 angles in a triangle. So measurement of angles within a triangle, okay? So we will look at graphs this week and equations next week. It is important that you remember basics about trigonometry. So there is an assignment there for you, or a task to go and draw the sine wave, a cosine wave, and a tan wave. Again, is to give you an idea so that you've got a better picture if you're asked to solve an equation, what it should look like in real life. Okay, so as a starting point, it's good to go through some of the basic trigonometry from National 4. So National 4, they've learned about SOHCAHTOA. And the other thing they've learned is Pythagoras. So you've done Pythagoras. So BBC Biteside video is there for some revision of National 4 if you think you need to brush back some of the trig. And there's a link with a video which may be helpful. So Desmos, you've seen that we use it quite a lot. If you want to do your graph on Desmos, then there is a couple of things that you need to be aware of. So first of all, you need to set your angles. So X, you need to change it to 360 degree, negative 360 to positive 360 in steps of 30, for example, and your Y-axis with negative 2 and 2. So on Desmos, if you click on that spanner there, it will allow you to set all these, which means if you type Y equals sine X, it would draw it for you. Okay, rather than you having to draw it, or you can copy the drawing from Desmos. All right. On your calculator, what is important? National 5, what you'll find is the angles are set into degrees for you. So if you go and study higher, you would need to learn about gradient, but for National 5, make sure that your calculator is showing a little D here. So if you see that D, that means you set in the correct angle, degree, unit. So if you're not too sure, you just press Shift mode, and then you just press 3. Shift mode to get this little menu, and then select degree by pressing 3. And you would see the D appearing on your calculator. If you use NCalcFX, I think you can just scroll through the degree. It will let you, but by default, they set it to degree anyway. All right, so this week's chapter 23, working with trig, introduction to trig. So it's a long lesson and there's a task. So make sure you've got your scientific calculator, square paper, some ruler to hand. So pause, because if it's long, they do say the span time, or the attention span time for children is their age. So I'm sure you guys are more than 20, I would say, some of you may not be, but 22 minutes should be bearable. There are no specific Leki exercise for you this week. So you've got a short assignment to complete. So exercise 23A, 23B, 23C. And you can look at Pegasus work for those who wants to do more. So only one piece of work to be handed in this week, sketching trig curves. A sine wave, a cosine wave, and tan. These are the three signals that we will use during our trig sessions. Any questions? I've been talking for about an hour, 15 minutes. I'm gonna probably stop hopefully this has been recording. Yeah. Where is the record button? So I'm gonna stop recording